All right, we're going to do one more rational function. This is going to be a rational function with a hole, and we're going to talk about the hole a little bit. We may do two. Okay, so here we've got this problem. I'm going to first factor. I'm going to factor this, and I'm going to get what numbers multiplied to give me the first and the last numbers multiplied. That's a times c, and add to give me 7. And that's going to be -6 and -1. There's no a. Remember how when there's an a value you have to divide. So I'm going to get x minus 6, x minus 1, divided by x minus 6. And I'm going to look and I'm going to say, okay, these can cancel out. That is going to be my hole right here. That is the hole. Actually. So if I cancel that out, I'm left with y equals x minus 1. That seems easy enough. But I've got this to deal with. So part of it, I'm going to be working with this. I'm going to notice that, so if I go to look at my x-intercept, where is my x-intercept? Well, that is where the numerator equals 0. So I'm going to take my numerator of this new problem and set it equal to 0. So I'm going to get 0 equals x minus 1, x equals 1. My x-intercept is going to be at 1, 0, because I know that the x-intercept is always where y equals 0. Right? So x is 1, y is 0. Secondly, so that's my vertical asymptote. I'm going to look up here. Set the denominator equal to 0. Okay, my denominator's gone. I don't have a denominator anymore. So I'm not going to have a vertical asymptote. The denominator is gone. It's vanished. Set for my horizontal asymptote. Okay, so for my horizontal asymptote, I'm going to look and see, all right, is this a Bobo? Is it a Botan? Is it an eats DC? Well, to look at that, I'm looking at my original function. Bigger on top. So this is a bigger on top Botan. So there will be no horizontal asymptote. None. Now, the hole. I do have a hole, and it is created by this. So in order to find the hole, I take what has been canceled out and set this equal to 0. So x minus 6 equals 0. And solve it. X is going to equal 6. So my hole is going to be where the x value is 6. Now I'm going to take this 6 and plug it into my simplified equation. So if my x is 6, y equals x minus 1. I'm plugging in the 6 for x, and I'm getting 5. So y is 5 when x is 6. There is my hole. So I'm immediately going to come over here, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, and write a big, huge hole. That is how I indicate that there is a hole, an open dot. So now when I'm doing my domain, x is going to be the set of numbers where x cannot equal my asymptote, which is none, or the x value of my hole, which is 6. X cannot equal that. And same with my Y value. The Y value is where Y cannot equal the horizontal asymptote, which is none, or the Y value of my hole, which is 5. So what is this graph going to look like? Well, let me see. I have a feeling I did something wrong here. Oh, no, that's right. Okay, so if I just graph it, clear, let's see. I'm actually going to put in this original equation. I'm not going to put in the simplified equation because I want to make sure that what I'm thinking is going to match that. So I'm going to put in parentheses x squared minus 7x plus 6 and the parentheses divided by parentheses x minus 6 and the parentheses and graph that, and what do I get? It's a straight line. It's a straight line. So I'm going to take my ruler, and though when I'm drawing this straight line, I'm going to leave the area of that hole untouched. And I'm going to go and look at my table and notice, okay, straight line, that's fabulous. And at x equals 6, it says error, as it should, because my hole is at x equals 6. All right, I'm going to stop this video. I'm going to do one more. Hope this is helpful.